All right, so it's been a while since we've talked about transforming graphs, it feels like, so we're just gonna transform a whole bunch just real quick so that we can remember what exactly happens.
This doesn't need to be hard, by the way.
It doesn't need to be, but you will have to refresh your memory.
Yeah, it'll be a refresher.
If our original function is y equals 3 to the x, we're going to apply each of these translations to it, transformations, I mean, and we're only going to apply that one thing.
Oh, we're not going to build.
We're not going to build.
Okay, sounds good.
So a vertical stretch of 5 is going to multiply your function by 5. If it's a vertical stretch, it just multiplies outside your function, and our function is 3 to the x.
Right.
So if it's a vertical shrink, we still multiply by whatever it is.
Right, because it's vertical.
Right.
Vertical is outies.
Okay. If it's horizontal.
That goes inside.
Okay. If it's a stretch of 4.
It's a reciprocal.
Then we do 1/4 x. Inside of our function here is the exponent.
Where the x is. Yeah, where the x is. Not the 3, it's the x.
Right. Another way you could write this is 3 to the x over 4.
Right. Both of those ways will be shown in your book, so be comfortable with both.
Yeah. So if I want to horizontally shrink by 1/6, that's in my exponent, I'm going to multiply by the reciprocal, which is 6. So that's 3 to the 6x. Reflection across the x-axis.
Negative.
Where?
Right in front of the 3.
Okay. Because here's how this works. If we're reflecting across the x-axis, we don't make x negative.
No.
When we reflect across the y-axis, we do make the x
That is
negative.
correct. Everything you just said is 100% correct.
Okay, so that's the difference between which axis you're doing. I don't know why this is underlined, but let's just we're
going to run with it.
So if it's shifted left 2, that's a horizontal shift, so that needs to happen in our exponent, and it will be super opposite society.
Yep.
Super secret society. So left 2 is normally left would be negative, so it's plus 2.
X plus 2. And now since we're moving left and right, we're going to actually manipulate that x guy. Just a little wee skosh right here.
Just like that.
Just like that.
Okay.
So this will be x minus 5.
Right. And if we shift up.
Back to horizontals, so that's to the whole thing.
Vertical.
That's what I said.
Yeah, okay.
Yeah. Why are you arguing with me?
I'm not.
I don't like your tone of voice right now.
Up 3.
Up
outside.
3 indeed. Totally outies.
Okay. And then down 4.
Minus 4.
Minus 4.
There you go.
So that's all of the different ways that we can translate individually. You could combine some things together.
You could have a total smash up of those puppies.
Yeah, but you really need to be getting comfortable at some point with how do you draw like 3 to the x? Well, you start at 1, you go up to the right, and you go down to the left.
Yes.
Closer and closer to 0. So now if I asked you to vertically draw something where you vertically stretch by 5, it goes up faster.
Goes up faster, falls down quicker.
Okay, and if we reflect it across the x-axis, we should be able to do that. That's the case where it would actually be down here, reflected across the x-axis.
Right.
So we need to be able to draw it initially, know what this looks like. If nothing else, plug in values, right?
Right. You can always just check a few values to get a good eyeball on it.
And then apply a transformation and see what happens.
Right, indeed.